Welcome to the Explainer. Today, we're going to do something a little different. We're not just solving a coding problem, we're actually going to decode how to think like a top-tier candidate. We're going to walk through a mock Google interview with two of their own software engineers, and it's basically a masterclass on how to solve problems under pressure. So, this quote from a Google recruiter, it basically lays out the whole game plan for us. They're telling you straight up, this isn't about just spitting out the right answer. The goal is to see how your brain works. Google wants to see the journey, not just the final destination. Okay, so here's the challenge. You get this grid of ones and zeros that represents a farmer's plot of land. The ones, that's good, farmable land. The zeros, bad land. Your job is to find the largest square of good land. Sounds simple enough, right? But trust me, there's a lot of complexity hiding in there. Now, before our candidate Sammy even thinks about writing a single line of code, and this is so important, he starts by asking questions. He needs to nail down the rules of the game first. And his first question is just perfect. Does it have to be a square, or could it be a rectangle? The interviewer says it has to be a square. That one little question changes everything. It seriously narrows down the problem and stops him from going down a totally wrong path. Okay, let's get into his first attempt. He immediately starts talking about what's called a naive solution, or the brute force approach. And the key here? He's thinking out loud the whole time. The idea itself is pretty simple, right? Just start at every single spot on the grid, and from there, check every single possible square size you can make. It would totally work eventually, but he already knows it's not the best way to do it. And he doesn't just say it's slow, he explains why. He points out its time complexity is O of n to the fourth. Now, what does that mean? In plain English, it just means that as the grid gets bigger, this method gets slow, like really, really slow. It's just too computationally expensive. And you know what? This is such a key moment. Spitting out the bad solution first was actually a brilliant move. It shows the interviewer, hey, I can come up with an idea, I can see its flaws, and I'm already thinking about how to do it better. He's showing his entire problem-solving process. So Sammy knows that brute force isn't going to cut it. He pivots. He starts digging into a more advanced idea to find a smarter way forward, and that idea is recursion. And the idea behind this is actually kind of elegant. It's this. If you're looking at a cell that's a 1, the biggest square you can build starting from that spot is directly tied to the squares you can build from its neighbors. So by talking it through with the interviewer, he fine-tunes the logic. It boils down to this. To figure out how big my square can be, I have to ask my neighbors, how big of a square can you make to my right? How about below me? And on the diagonal? The answer is simple. My square can be 1 bigger than the smallest of those 3. Okay, so recursion is smart, but it's got a big problem. It keeps resolving the same little problems over and over again. And that realization leads him to the most efficient solution for this kind of problem, dynamic programming. So what he suggests is building a whole new grid. You can think of it like a cheat sheet or a cache. It's often called a DP array. Instead of redoing the math every time, he'll just store the answer for the biggest square that ends at each cell. That way, you only solve each piece of the puzzle once. This is really the whole point here, this shift in thinking. Recursion is top-down. You take the big problem and smash it into smaller pieces. But dynamic programming, that's bottom-up. You solve all the tiny, easy problems first, save the answers, and then use those answers to build up to the big solution. Yeah, this visual really helps it click. On one side, we've got the original grid. On the other, you see this new DP array getting filled in. To figure out a value for the DP array, you look at the original grid. If it's a 1, then you peek at the 3 neighbors, top, left, and diagonal, in the DP array you're building. And this right here, this is the magic formula. It's the heart of the whole thing. The value for any spot in our new grid is just 1 plus the minimum value of those 3 neighbors we just looked at. It's so simple, but so powerful. So the interviewer gives him the green light, says the logic is solid, and now comes the moment of truth, turning this great idea into actual code. And remember, he's doing this without a compiler to help him out. All right, so the coding starts with a little setup. First, you create that DP array, same size as the original, and just fill it with zeros. Second, you make a simple variable, maybe call it maxNum, just to keep track of the biggest square you found so far. Okay, next up is the main engine of the code, a loop that goes through every single cell. If the cell in the original grid is a 0, well, that can't be part of a square, so we just ignore it. The spot in our DP grid stays 0. But if it's a 1, Boom, we use our magic formula. So for every 1 he hits, he calculates the new DP value. And right away he checks, is this new number bigger than my current max? If it is, he updates his tracker. Then, after the loops are all done, he just takes that max number, squares it, and that's the area. Done. So the code works, it's efficient, it's great, but like we said right at the start, getting the answer was only part of the test. The real test was showing how he thinks. And this final comment from the interviewer, it just says it all, doesn't it? The path he took, from the slow brute force method to the better recursive idea, and finally landing on the optimal solution, that wasn't him making mistakes, that was the exact problem-solving journey she wanted to see. So, what can we take away from all this? What are the real keys to a Google interview? It's not just about being a coding wizard, it's a test of how you communicate and think on your feet. You gotta explain what's going on in your head. You have to ask questions to make sure you're on the right track. And this is the big one. You have to show you can look at your own idea and say, I can do better. And really, that's the big idea here. When you're tackling a complex problem, whether it's in a job interview or just anywhere, the way you get to the answer is often way more important and way more telling than the answer itself.